Hello, this is extraction of acid, base, and neutral semivolatile organic compounds in water and wastewater, also known as EPA method AD270. Some of the analytes in this method are completely polar. This necessitates the use of two stacked SPE cartridges. An activated carbon cartridge is used to extract the polar analytes, and a newly developed sorbent is used to extract the remaining analytes. This 500 milliliter sample has been pre-treated with 40 milligrams of sodium thiosulfate to remove residual chlorine. The sample pH was adjusted to less than 2 with a strong acid, and then spiked with surrogates and target analytes. Adjusting the pH of the sample to 2 or less is extremely important. Remember, the pH of deionized water cannot be accurately determined using pH paper. First, we connect the carbon cartridge to the bottom of the AD270 cartridge using an adapter. The carbon cartridge must always be on the bottom. For samples with high particulates, a plug of glass wool inserted into the top of the cartridge will prevent clogging. This extraction can be performed on a standard glass block manifold or on the disc manifold apparatus shown. Attach a UCT clean-through tip to the bottom of the carbon cartridge and place it in the glass adapter to make a seal. In this demonstration, we are showing a single extraction. In a high-throughput lab, multiple stations or glass block manifolds will be used for efficiency. 5 to 6 hours are required to extract and concentrate a typical batch of 24 samples. The cartridges need to be pre-washed to ensure that no contaminants have been picked up during handling. Wash the cartridges with approximately 10 milliliters of methylene chloride. Allow 1/3 of the volume of the solvent to pass through the cartridges, and then let the solvent soak for at least a minute. Then draw the remaining methylene chloride to waste. Leave the vacuum on for about a minute or so to remove any residual solvent. Next, we want to condition the cartridge. Add approximately 10 milliliters of methanol to the cartridges to increase the activity of the sorbents. This can be drawn straight through the cartridges. Lastly, we will need to equilibrate the cartridges with about 10 milliliters of reagent water and 10 milliliters of 0.05 normal hydrochloric acid. Again, these solvents can be drawn straight through the cartridge. Now we are ready to load the sample. Start by connecting the large sample delivery tube to the top of the 8270 cartridge. Insert the stainless steel end into the sample bottle, turn on and adjust the vacuum for a fast drip sample flow, about 10 milliliters per minute. Once the entire sample is passed through the system, turn off the vacuum and vent the manifold. Rinse the sample bottle with about 10 milliliters of reagent water and apply the bottle rinse to the cartridge. You can tilt the bottle slightly to get that last drop out. Now we can disconnect the sample delivery setup. We will dry the 8270 cartridge under full vacuum for 10 minutes and the carbon cartridge for 15 minutes. We need to remove as much water as possible because wet sorbents can cause poor recovery. Our next step is analyte elution. Remove the glass adapter from the manifold and insert a glass vial into the base of the manifold. In this demo, a 50 milliliter glass vial is being used. However, other suitable glass containers may be chosen for eluent collection. Reattach the glass adapter to the manifold. The analytes bound to the two cartridges must be eluted separately. Insert the 8270 cartridge into the adapter. The 8270 cartridge is eluted with one 5 milliliter aliquot of ethyl acetate followed by two 5 milliliter aliquots of 3% ammonium hydroxide in ethyl acetate. And lastly, 5 milliliters of methylene chloride. After the application of each solvent, we want to draw about 1/3 of the solvent through the cartridge and then allow the remainder to sit on the cartridge for at least 2 minutes. Then draw the remainder of the solvent through the cartridge, 1 drop at a time. You'll need to make up the 3% ammonium hydroxide solution in ethyl acetate on a daily basis from relatively fresh ammonium hydroxide. Ammonium hydroxide is extremely volatile and loses its strength very quickly. This can result in a lower than needed pH and poor recoveries.
I'd rather just, I'd rather keep rolling now and get it all.
Yeah, right, that's why I was like,
It looks great.
I think it's kinda good the logo's not away in that tube in the middle, right way you can see that, you know, what's happening in there.
For analysts that prefer calibration standards prepared in methylene chloride, there is an alternative extraction procedure that you can try. You can eliminate the use of ethyl acetate in the extraction procedure by using straight ammonium hydroxide and methylene chloride. If you use this process, you will need to change a few things. In the first dilution step, apply 10 milliliters of methylene chloride to the 8270 cartridge. Allow them to soak for 2 minutes and then elute dropwise. Add 1 milliliter of concentrated ammonium hydroxide to the cartridge and allow it to thoroughly sit and soak the cartridge for at least a minute, since it is not soluble in methylene chloride. Finally, add an additional 10 mL of methylene chloride, soak, and elute dropwise. We have placed a 50 ml vial under the carbon cartridge. Elute the carbon cartridge with 3 5 milliliter aliquots of methylene chloride. Again, we make sure to soak the sorbent for a few minutes and then elute drop by drop. We're now pulling full vacuum through each cartridge. Minor adjustments to the stopcock allow you to control the drip rate. As you know, there's always some water remaining in the final extract. You can use your own sodium sulfate drying method for water removal as long as it works well for you. Don't use filter paper to hold the sodium sulfate, since we are not using enough solvent to rinse the analytes out of the paper. Here we are using a fritted reservoir containing around 15 grams of sodium sulfate. Pre-rinse the sodium sulfate with methylene chloride to remove any contaminants. After the pre-rinse, insert a glass vial into the manifold to collect the dried extract. Dry the extract from the 8270 cartridge first. Then dry the extract from the carbon cartridge. Even though it's not featured in this demonstration, be sure to rinse the vials and add to the final extract. Rinse the original sample bottle with 5 milliliters of ethyl acetate, or if you followed the methylene chloride method, use 5 milliliters of methylene chloride. Rinsing the sample bottle is a critical step for removing analytes that are adsorbed to the glass. PAHs are a good example. Transfer the bottle rinse to the sodium sulfate. This also is a good way to rinse the sodium sulfate. And of course, collect the solvent in the sample extract vial. Repeat this step with another aliquot of 5 milliliters of methylene chloride. After all the extract is passed through the sodium sulfate, you can now evaporate the sodium sulfate to a 1 milliliter final volume. Add your internal standards, and you're ready to inject your sample into your GCMS for analysis. Thank you very much for watching UCT's presentation of the solid phase extraction of EPA's method 8270. If you have questions about this method or any other solid phase extraction, please contact us at methods@unitedchem.com.